Hello, welcome back to really just welcome to the second part of the tutorial series for the quaternion transform rotation stuff. I don't know how I'm going to title this. I'll figure out something. But basically, this is part two. Here's what our end result is going to be pretty much, where the transform is going to stay attached, and we're going to move it around, rotate, that kind of fun stuff. I can still move the actor around and it will still update. So let's build out that actor. This is the finished version, so for this episode. So we're going to go into YouTube tutorial and we're going to start making our dude, our chair, get the child actors transform and everything. So first what we need to do is make a bunch of functions. Uh, so first we're going to do is get actor quat in world space. So I'm going to do parentheses world. I have my notes open on my other monitor, so if I move my mouse off to the screen, it's mainly just so I have my notes. So we're going to do get actor rotation. By the way, I just did a add return node, so that way I can return out a quaternion. So we're going to quat. And you may be wondering, why are we using quaternions? Why can't we use rotations? It's mainly to get the idea and the concept across that like quaternions aren't scary. They're really not. Um, and hopefully to help you get more comfortable by using them rather than like talking about using them. Um, but you can do the same operations with rotators. You can do uh, multiply. Whoops. You can do that. You can do combine rotators, which is basically the multiplication. You can also do inverse. So, whoops, wrong one. You can do invert rotator. But yeah, it's the same thing, same concepts. So then we're going to do get actor quat local. And it's basically, I'm just going to copy and paste this to save time. Bring this over here. Straighten that. Actually, I'll straighten after. Inversed. And return node. And I'm just going to plug this straight into here. Make this const pure. I also made the other one constant pure, by the way. Um, just so I can quickly drag it out and be like, I just need to get the value. So next, what we're going to do is we're going to do our conversion functions. So we're going to make one of them. We're going to do, probably the easiest one would be local quat to world. And we're going to throw this under the category conversions. Okay. So inside this function, we're going to use the world quaternion. We're going to multiply it. And then we're going to make the input parameter be quat. And let's do local quat to convert. Make it easier to understand. So pure const. Let's do a return node. Let's drag that into here. And we're going to compile so I can get the property local quad. Yeah, there we go. To convert. So what is happening here? What are we doing with this? So let me use my comment bubbles and my pictures to help me out. So we got chair, and I'm gonna pretty much orient them to the size of these like grid blocks that Blueprint has, which are pretty handy. That's how I usually figure out this kind of math. So got chair, got cone, and you might hear my cat meowing in the background. You got center of world. Also, let's just remember it is 0, 0, 0 on all axes. So let's move that over here. All right. And when I say center world, I literally mean center world. So imagine we're doing this all really in world space, because world space is really just the idea of like, okay, we're doing it in relative of something, or if we're just doing it in the world where, everyone's using the same transforms, but it's just for us to understand, as programmers, um, and mathematicians and stuff. So like it realistically is in the same space, like in literal terms, if that makes sense. Um, So we got our chair here, okay? This is in the world space. We just got its rotation and we're like, okay, this is our rotation. Let's do X, make this really small. I don't know why it's having trouble with like scaling it. Might be a bug in the engine. Just do Y, and Z is, center. It's going to be center the whole time, so no point in showing it. But the same concepts apply. So we have our X and Y, and he's the facing in that direction, Let me move this here. So they're facing in that direction, and the cone is facing away from him. Okay, so in this case, pretty much what we're doing is in relative space, the cone is maybe like let's figure it out. So he's facing away. So let's say this is the center of the world's forward and right direction. And we're doing the cone in relative space. So like, let's imagine this is where the cone is actually, in the world, and this is where the chair is and where it's facing and all that fun stuff. Let's do this actually. Um, yeah, move this guy over. And the cone, let's say he's over here in relative space, I think. I don't know. Um, so then it would be up here. Yeah. And he's facing away from where we are. Actually, it's supposed to be, so this is forward. Okay, that's forward. So going back one, so back one, and then to the left, so 1, 2, 3, and 1, 2, 3, and then this guy. So he would be over here, and X would be, sorry, I'm just literally trying to figure this out. All right, so it's going to be on this direction and this guy because he's facing, it's basically just like a mirror from each other. So this is the relative space, like rotation and everything. And then what we're doing here is we're using the world rotation, which is this guy, and we're saying we want to convert this, to be in relative of this guy. So it, sends it over to this guy's rotation. So really, it's going to automatically rotate out to become this guy again. If I was to flip it, so like that, oh man. Um, so if I was to flip it, it would basically do the inverse of that, where it's like, okay, this is my relative space. So now this is, imagine like this is the center of the world instead, and this guy is getting converted into the relative space of this guy. So it's like if we were actually putting this guy over here, um, let me do that, and this guy was actually here, So that's basically what the order of operations is when you're dealing with local rotations and world rotations. So if we go to make another function, let's do local location to world. Throw that under conversions. And in here, we're going to get our world rotation. And the way we would do that with, because we can't multiply it by vectors in Blueprint, we would basically just call rotate vector. That's basically the same thing as doing like multiply, but with a vector. And the funny thing is, you can do this, and then let me make an input parameter, vector. Let's call this local location to convert. Okay, get local location to convert. I can drag this into here, right? Like it shows up and everything, and yet doesn't let me. So just wanted to bring that up because I thought it was funny. So the interesting thing with these, when you convert it from local to world in this case, is that, let me grab our example over here. I gotta reset them. All right, so in this case, now we're converting cone's location, x, y coordinates into the world version. So it's sending it back out to where it should be, which is over here. The rotation hasn't been fixed. So let's just imagine it's still rotated like this. Okay. So, oh yeah, and when we were doing it in here, just imagine that the location was still the same. So it was still sitting here, it's just the rotation was fixed. But so basically what we're doing with the location is transforming it so it's going to be in world space again. But it's not going to be within the relative offset of the chair is the thing. Because the location we're actually going to convert is the offset from this. Because when we convert it into from relative to world space, it's going to be like, let's imagine location is X. Actually, let's do it like this. So let's say 500 and 3 and no wait, 78, 6, and then 92. And those are the actual world coordinates of the cone. Whereas if we did it like the offset instead, which is going to be like 3 and 1 and 0. So 3, 0, and 1, that same offset is going to get transformed over to here. Whereas if we did it with this, when we tried to transform it, it's going to go off like, 500 units, whatever, in relative space. So, yeah. So when we convert it back out, we're just going to go, okay, we just want to convert the offset back out, and then we want to rotate it so that way, it's in the current world's rotation. It's like you may be thinking like, well, why don't we just add the offset here? Well, that's the thing is when you re-add the offset without rotating it, it could be like the chair is now rotated in a different orientation from where it is in the centered world. So calling rotate vector will basically put it in like its relative rotation state and bring that over so that way it's like shifted over where it should be. And then the offset is just to position it properly. So, and if you don't know what I just explained, like you can always just break these apart and literally plug them in separately and then play with it. So that's the fun with math. You can always just play with this stuff and it won't break. So we're gonna add our get actor location. Man, my computer is like struggling right now with doing this while recording. Return node, and we're gonna return the result. So we have our rotated vector, which is really just converting it into world space, and then we're adding that offset, so that way it's positioned in the right spot. So hopefully that makes sense. And then we're going to go into the world location and the world locations and world rotation. So world location to local. So this is us converting it to local space. Convert, there we go. And vector, perfect. World location to convert, pure const do return node. So I'll just add it now. And what we're going to do is we're going to get the local space rotation now. And we're going to do rotate vector, as you may remember I just told you. And then we're going to do get world location to convert. And we're going to get the difference from our current actor's location. So get actor location, since it is the parent. And that's the thing we're going to feed in, we're going to convert into relative space is the offset. So, because this will create an offset essentially, or the distance from the distance or the offset, you know, they're used interchangeably, used like when we do these subtraction of vectors, but the idea is like it's the difference. So like the line from here to here, you know, line from the chair to the cone. That's our offset. And then we're going to do that for world plot to local. I'm going to move that in here for organization purposes. And then we're going to plot world quat to convert. And we're going to add the return node, compile, save. And for converting that, it's pretty much the same thing we did with converting local quat to world, but instead of using the world rotation, let me clear out these tabs so it's a little bit easier. Navigate. We're going to use the local rotation. And again, the order does matter here as well. So, oh, right. We're basically having to do like, okay, world quat to convert. So now like you have to consider it like this is the root rotation that we're basing it off of. And then this is the one that's being appended or the different or finding the difference of that kind of thing. So yeah. Let's make this pure and const. Did I forget the other ones to make them pure and const? No, I didn't. All right, perfect. So let's compile that, save, make sure these are all pure and const checked. And that's just so we can quickly kind of drag them out and be like, run this. So now we have our conversion function set up. Let's go into store transforms. And this one, we pretty much are going to set it up initially and then be done with it for even the next tutorial. So first, we're going to make a new variable, and this is going to be our actual child actor. Object reference, and we're going to make it instance editable so we can select it in the viewport. We're going to drag this guy out here as a get, and we're going to right click and convert to a validated get. This is just so I don't have to do like a is valid and, you know, more nodes kind of thing. Then we're going to do is get actor location and promote that to a variable, not a local or temp variable, just a regular variable. We're going to call it world initial attach location. And we're going to connect it to the is valid, and we're going to continue from this pathway. And if it's not valid, nothing happens. So, all right. Next, we're going to drag the child actor out again, get actor rotation, and to quat. Do that. And we're going to right click and promote that to a variable, and we're going to name it world initial attach quat. We're going to connect that up. So now we have our world and our world location and rotation being saved initially. And remember, in the event graph, this is in begin play. So store transforms, we're doing that. Next, we need to actually use our conversion functions. So we're going to do world location and world quat to local. We're going to convert these variables that we just made and convert them into local space. move this over. Okay. And then we're going to promote these guys as well to variables, and we're going to call them local initial attach location. Do that. And same with this one. We're going to promote it to a variable, local initial attach quat. Almost said rotation. And compile, save, and that's it for this function. We're never going to be touching this guy again, really. I mean, inside it. So we can close that tab. Now we're going to go into tick transforms. So for now, we're not going to actually be moving the actor. We're just figuring out the math behind some stuff. So I'm going to drag out child actor, and then we're going to get its actor location. And we're going to promote this to a local variable. We're going to call it temp current world location. Oh man, why is my editor stuttering? All right, then we're going to drag this guy out, get actor rotation, and you can guess we're going to plot, convert it to a quaternion, and then we're going to promote it to a local variable, and it's going to be named temp current world quat. Let's connect that. So those are the important parts of this function done. Let's compile, save. Next, we're going to draw debug coordinate system. Okay, so then we're going to do is get our local initial attach location. So we haven't moved the initial attachment location at all. Like we haven't moved it. So if we do local location to world, basically it's going to be relative to our YouTube tutorial actor, so the chair. So it's not even going to move around really. Or it will, but it'll move relative to our chair rather than like we haven't moved it around in relative space of our chair. So I'm going to drag out of here times 2, get world delta seconds. This is just for drawing the debug stuff, and so we can see it. And I'm going to change the thickness to 2.5. The scale will be 100 because I already kind of checked this ahead of time of like which one's right, so we're not spending time playing with that just to be able to see stuff. And the same thing goes with our quaternions. So we're not using these guys yet. We will be when it's time to move the actor. Okay, so let's convert this guy, this local quaternion, into world space. We're going to connect that up. There we go. Move this over, compile, save, and I'm going to drag out YouTube tutorial guy, throw him in here, and we're going to select our actor, which is the cone. It says right there, cone. And we're going to hit play. And as you can see, it stays oriented. So if you want to right now, we can totally just use this for like setting the actor's location. So like set actor location and rotation. Let's do that, that, that. Ta-da! Sorry if it's laggy. My computer's like acting weird because of OBS. But yeah. Now the important thing is if you try to rotate him, you see it's going to fight back. So, we have some basic stuff, but it's obviously work in progress. So, but yeah, hopefully that was helpful. Pretty much the reason why we're storing these values is just for later in the next tutorial. And same with these guys is for the next tutorial. But the main pieces of this one is that we're saving the local initial attach location and quaternion, which if you remember in the store transforms is this part. And this is only happening in begin play. So in the first frame of the game playing, we're storing the relative space, like positioning of the cone, relative to our guy. And then we're converting it back out into world space relative the relative spot now converted into world space. And you may be thinking, okay, shouldn't the engine like do this automatically? Like, isn't there functionality I can just use instead of having to do all this math? You're correct. And that is by using get actor transform inverse transform location inverse transform rotation. Same exact things. This is literally what we're doing essentially. The actor transform is in world space. So if you want, this will convert it, as the comment says at the very end, from world to local space. And if you want to do it from local to world, you just do transform location, transform rotation. So we can even do this right now if you want. Let's actually do that. So I'm going to plug these guys into here. And just because we're using quaternion, because there's no setup ones for, the quaternion ones. Um, so I'll delete these guys, plug this here. Sorry, it's going to look a little bit messy, but, this is just showing as an example. Let me move these guys here, because then we can just delete it when we're done. And then we're going to go over here. And I haven't even messed with the other one yet, but as you can tell, it's still using the correct stuff. And then if we go back here, go to tick transforms, we're going to do get actor transform, transform location, transform rotation. Whoops. And we're going to copy these guys over. Boop. Boop. And I can just plug this guy here. Plug this guy here. And as I'm hitting play, you can see it basically didn't change at all, but it's the same. It literally is the same, like, calculations and stuff. So at least you understand like how it literally is built out on how it does that math, which is always fun. The more you know, right? So in the next tutorial, we're actually going to deal with offsetting it. So that way, when it's attached, actually, let's actually just leave it as like it's setting its location and rotation. Set actor rotate location and rotation. And we can delete this one. Plug you in there. File, save, and hit play. So yeah, we can move the cone around, stays relative to the chair. If this is what you're looking for, great. I have given you the answers on what you need. Um, if you're having snapping on, it's going to kind of like be a little bit janky because it's in editor and it's dealing with the snapping. In code, you can obviously just organize the order of operations that are happening. So it's like do the snap after, everything's been converted, or, do the conversion and then snap the offset or rotation or something like that. But, it's the same kind of concepts. Um, it was just because like we're fighting with the editor at that point when having snapping on. So, hopefully this was helpful. Let me know if it was. Um, in the next tutorial, we'll actually go into the offsetting and everything. So other than that, I hope you have a great rest of your day.